So my name is Chris Henry. I'm at Argonne National Lab in Illinois. My expertise is metabolic model reconstruction and I'd say platform development for multi-omics data integration. My passion is understanding microbes, microbial life, microbial evolution, but I'm passionate about building a platform like K-Base, and that may seem weird, except that to me, having platforms like K-Base that facilitate data integration and tool integration and keeping the science with the tools and the data that went into the science all together in one place and sharing that is so critical. Oftentimes we try to learn what's happening in these systems by focusing on individual functions or reads or individual metabolites, and I always find that something that's doomed to fail because we're individual species. So, the problem is this one proteobacteria. That's what's causing the disease, except now you look at a new patient and you don't see it there. And that's because we focus on too low a level and there's too much diversity in these systems. And so you just get too much variability, too much noise. This particular guy doesn't have that function, he implements it a different way. And so I don't see what I was expecting to find in my data. The value of models is it takes us to a higher level. It's not the individual pathway you use to make butyrate, it's the fact that you make butyrate. And it's being able to use modeling to jump from the low level function to butyrate synthesis is important. And let's find all the pathways that can make it, and then we know who's making it in any particular microbiome data set. I have to have systematic approaches, and I have to apply them consistently. By doing that, it stops becoming an avalanche, and the data is organized, and we can make sense of it. I think machine learning is another huge asset to deal with the data avalanche. AI has this amazing ability of looking at all the variation and teasing out the important pieces of data from which we can we can draw conclusions. So we can explain like our phenotypes and then being able to make predictions in other systems. But again, machine learning depends utterly on data being organized, consistent, using a controlled vocabulary for functions, consistently assigning protein families, using a controlled vocabulary for compounds and reactions. No, we can't all use our own namespace. All of that has to be consistently applied. Again, I think this is why I think the virtual human site is such a great resource, because this is something you guys have done for the microbes on the site and for the human systems on the site as well. The data should be good, but instead it can be a liability, and the reason is because what do we do with data? We publish a paper and we scatter the data to the winds. 18 different repositories. I got a separate repository for microbiome, a separate repository for short reads, a separate repository for genomes. Not even a link between them. And so, the only link is the publication, and you hope that that author did their job or that reviewer did their job and pointed out, I can't make heads or tails of your data, and you have to fix this before this paper can be published, and that's not happening. So we have to do a better job of connecting data together, of when we publish work.